1. Hook. Have you ever wondered if your AWS bill feels a bit too high? You're not alone. One service quietly sucking your budget dry is AWS Lambda. You might think you're saving money by using serverless, but without oversight, you might end up paying significantly more than expected. 3. The simple explanation: request count. You get charged for the number of requests. The first million requests are free, but after that, you pay 20 cents per million requests. Duration: this is the time your code runs. You are billed based on the GB seconds used. For example, if your function uses 128 megabytes of memory and runs for 1 second, that's 0.00003125 gigabytes seconds. The cost can add up quickly. A simple function running frequently can lead to unexpected charges, especially if it's invoked more times than planned. 4. Real-world example: let's say you run a startup that uses AWS Lambda to handle user signups. You set your function to trigger every time a new user registers. Initially, you expect about 1,000 registrations per month. Your function is lightweight, running for about 500 milliseconds, consuming 128 megabytes of RAM. Here's the math: requests, 1,000 registrations equals 1,000 requests. Duration: 1,000 requests 0.5 seconds equals 500 seconds. In GB seconds, this is 0.00003125 times 500 equals 15.625 gigabytes seconds. 1,000 requests equals $0 to 15.625 gigabytes seconds equals $0.000046. But what if your marketing campaign goes viral? Your user signups skyrocket to 100,000 per month. Now, let's recalculate. Requests: 100,000 requests equals 2 cents. Duration: 100,000 requests 0.5 seconds equals 50,000 seconds, translating to 1,562.5 gigabytes seconds, costing you about 50 cents. Suddenly, you're looking at a total of 52 cents for 100,000 requests. Still manageable, right? But imagine if your function had inefficiencies or bugs that made it run for 5 seconds instead of 0.5. Your costs could explode. 5. What to do instead? Let's break down how to manage AWS Lambda costs effectively. Step 1. Monitor usage. Set up AWS CloudWatch to monitor your Lambda metrics. Check the request counts and duration regularly. Use alarms to alert you when usage spikes. Step 2. Optimize your code. Avoid long-running processes. Use efficient algorithms. Analyze your function's execution time and memory usage. Step 3. Adjust memory allocation. Test different memory sizes. For many functions, increasing memory can reduce duration due to better CPU allocation. Use the AWS Lambda Power Tuner tool to find the right balance. Step 4. Set timeouts. Set a reasonable timeout for your Lambda functions, typically between 3 to 5 seconds. Use error handling to catch and retry failed executions rather than letting them run indefinitely. Step 5. Implement throttling. Use API Gateway to throttle incoming requests. Limit the rate of requests to avoid unexpected spikes. Consider implementing a queuing mechanism using Amazon SQS if needed. 6. Common mistakes. 1. Ignoring monitoring fix. Set up CloudWatch alarms for request counts and execution duration. 2. Over-provisioning memory fix. Test various memory settings. Start with the lowest and increase only as needed. 3. Not setting timeouts fix. Always define a timeout to prevent runaway executions. Aim for 3 to 5 seconds based on your use case. 4. Failing to optimize code fix. Regularly review and refactor your code for efficiency. Use profiling tools to identify bottlenecks. 5. Neglecting error handling fix. Implement proper error handling and retries to manage failed executions without incurring additional costs. 7. Quick checklist. Set up CloudWatch monitoring. Regularly review function execution times. Test memory allocations and optimize. Define timeouts for all functions. Implement request throttling. 8. Summary plus CTA. AWS Lambda can be a fantastic tool, but if not managed properly, It can lead to unexpected expenses. Monitor your usage, optimize your code, and set clear boundaries. If you found this video helpful, hit the like button, leave a comment with your experiences, and don't forget to subscribe for more practical tech insights. Bonus practical tip: if you're unsure what to pick, start with the simplest option that ships today. Then measure for 7 days, latency, errors, deploy time, and cost. Only upgrade when metrics force the decision, not fear. Quick recap: keep it simple, avoid over-engineering, and build the smallest thing that works. If you want a real demo or checklist, comment demo. Subscribe for practical AWS, DevOps, Docker, and Kubernetes lessons.